Good morning, Trig. I'm going to cover kind of an interesting lesson going over the ambiguity when we're using our trig function. So it starts out by saying what we already know. A triangle has 6 parts. We have 3 sides plus 3 angles. If we are given, though, a pair, so a pair of angles or a pair of sides, and a third value is another side, and there is no drawing, then more than one triangle is possible. And so we're going to go over that today. If we're not given a drawing, then we can draw different triangles and assume different things about it. And so we're going to have to solve given both possibilities. So stick with me through this. So example 1, if they tell me I have a triangle where angle A is 40 degrees. So let's say I picture this in my head, 40 degrees. Right, this could be 90, that could be 50. If this is A, right, then A is 4. And then one of these is 9. Let's say this is 9. I could also draw, let's say you picture this when you see this triangle. So here is 40 degrees. That would make this 4. And let's say, I don't know, let's say this is 9. And same here, right? This could be 9. Or this could be 9. So let's say C is 9. Now in both of these cases, right, I don't know, like we all picture things differently. So there are 2 different triangles possible. So if we start to solve, so let's say the 4 over the sine of 40, right, should be equal in this case to 9 over, this is C, the sine of angle C, right? So that would tell me that the sine of C is equal to 9 times the sine of 40 degrees divided by 4. So 9 times the sine of 40 degrees divided by 4, and I get 1.446, and then I would have to do sine inverse of 1.446 equals angle C, and I get domain error. That is true. There is no sign relationship that's going to give you a decimal greater than 1, so I end up with an error. So in this case, if I end up with an error, then no triangle exists with these dimensions. Next one, given that angle A is 27 degrees, side A is 5, and side B is 7. So I'm not going to actually draw a picture here. I could have several different possibilities. I could have an acute triangle, or I could have an obtuse triangle, right? I could have a acute, or I could have an obtuse. I have 2 possible triangles that I could draw given these dimensions. So we're just going to go ahead and find all of our missing pieces. So I know that these have to be across from each other, right? So 5 over the sine of 27 degrees will equal 7 over the sine of B. So 7 times the sine of 27 degrees divided by 5 will equal the sine of B. So I'm going to simplify the left. 7 times the sine of 27 divided by 5, and I get I deleted it in my calculator. So I get 0.6356 equals the sine of B, right? So then we take the sine inverse of this decimal. And I get angle B is 39 39.5 degrees. Now, that is if this would be the acute triangle. But it is possible if this is 27 and this is 39.5, then it is possible that this angle here would be quite large. Or it's possible on the other side that I could have 27, a very large, two really small angles. So the other possibility would be 180 minus 39.5, which would give me 140.5. Make sure I did my math. Yes. So I have two possibilities for angle B. This would be in the obtuse triangle. So I have two possibilities for angle B. And hold on, 180 minus 27. So I have to find my dimensions for both scenarios. So angle B equals 39.5 degrees. And what if angle B equals 140.5 degrees? So for example, I think it would be better. I kept debating whether, if I wanted to like draw a picture of what they've given me, I could say, let's say I picture this is 27 degrees, this is 5, this is 7, and this would be angle B, this would be angle C. Or I could picture maybe a triangle like this, 27 degrees, this is 5, this is 7, and this is angle B. So there are two possibilities, that angle B is acute or that angle B is an obtuse angle. So I feel like that is a better picture. That I could draw two different triangles here. So I have to consider that angle B could be both acute angle or obtuse, one less than 90, one greater than 90. So so then I have to figure out the missing parts based on these pieces of information. So if angle B is 39.5, that would make angle C 180 minus 27 minus 39.5. That would give me an angle C of 113.5 degrees. If angle B is 140, then angle C is only 12.5 degrees, right? Because it's just 180 minus your two angles, so 27 minus. And then side C is the only missing piece. So I could say 7, and it doesn't matter which pair you use. You could use 5 over the sine of 27 degrees equals C over the sine of 113.5. So 5 times the sine of 113.5 divided by the sine of 27, C equals 10.1. However, over here, 5 over the sine of 27 equals C over the sine of 12.5, because the angle C is only 12.5 here. So 5 times, I'm cross multiplying the sine of 12.5 divided by the sine of 27, and on here I get that C is only 2.38. Which would make sense, right? Here's C, and here's C. And so these are both my answers because I'm considering that there are two possible triangles. Right. So we're going to do two more. I'm going to kind of change the way the information is presented. So next example, I'm going to use shorthand. A triangle has a 45-degree angle. A side adjacent to this is 10 units long, and a side opposite is 6 units. Find the lengths of the other sides. So the reason that that is in plural is that I have two possibilities. So I like to draw a picture. So picture this. They're saying a triangle has a 45-degree angle, and it says a side adjacent to this is 10, and a side opposite is 6. Or, right, if this is 45, a side opposite is 6, but this could be your adjacent side. So there are two possibilities here, and so I'm looking for both this side and this side, if possible. So I'm going to start over here. 6 over the sine of 45 equals 10 over the sine of angle B. I'm going to just start solving. I don't know that this is a 90-degree angle. I know I kind of drew 90-degree triangles, but I don't know that this is the right triangle. So that's why I can't use a squared plus b squared equals c squared. So if I solve this, I have the sine of b equals 1.18, and I end up with an error. So no triangle is possible with these dimensions. So if you get an error, now you know what to do. So last one, a triangle has a 30-degree angle. Side adjacent has a length of 10, and side opposite has a length of 7. So draw triangles and find missing sides. And remember, sides is plural because there's two possibilities. I could have 30 degrees. It says side adjacent is 10, side opposite is 7. But I also could have, right, this is 30 degrees, and this is 7, and this is 10. So I could switch where I put the, and I should change how I draw this, where I put the 10. So in this, I'm going to find both this possibility and this possibility. Or if it helps you, I could have drawn the exact same triangle if this was 7 and this was 10. What is that side? So two different possibilities. So here we go. For this one, right, 7 over the sine of 30 degrees. I'm going to make this B equals 10 over the sine of B. And then I can find C and X. Okay, you can make whatever letters you want. So I get the sine of B would equal 10 times the sine of 30 divided by 7, which is 0.7143. And let me confirm that because I'm 10 times the sine of 30 divided by 7. Yes. And then sine inverse. And I get angle B equals 45.6. which would mean that angle C equals 180 minus 30 minus 45.6. Gives me an angle of 104.4 degrees. So to find that missing side, I would say 7 over the sine of 30 equals x over the sine of 104.4 degrees. So 7 times the sine of 104.4 divided by the sine of 30. So in this case, one possible side is 13.56. Sorry. So there's one possibility when you put the adjacent side here. If I labeled this side 10, then it changes things. So in this case, I would say 7 over the sine of 30 equals sorry, 10 over, I set this up wrong. Sorry, guys. And so what is this missing side? So these are across from each other, and these are across from each other. That's where I messed up. Here is the acute version. Angle B, the obtuse version, is just 180 minus 45.6 because that's an obtuse angle. 180 minus 45.6 is 134.4 degrees. So I have to make both scenarios where the angle B is acute, that's one possibility, or if that angle was obtuse and I drew the 10 up here. And so in this case, angle C would be very small, right? 180 minus 134.4 minus the 30 degrees you already have. I now only have an angle C of 15.6. And then to find this missing side, 7 over the sine of 30 equals y over the sine of 15.6. I feel like I set that up wrong. 7 over 30, 10 over c. This would be y over angle B. Hopefully it comes out. 7 times the sine of 134.4 divided by the sine of 30. No, this should be 15.6. Did I set? Sorry, I set one of these up wrong. Like I know it should be over. So, sorry, sine of 15.6 times 7 divided by the sine of 30, and y equals 3.76, which makes this drawing not make sense. That's why. It's my drawing that doesn't make sense. I was like, wait, okay. Let me redo my drawing of my triangle. Don't mind me just trying to draw an accurate triangle. Hold on. See, this is terrible. It's better. Sorry. These are the two possibilities. One based on the acute version of B and one based on the obtuse version of B. My drawing was what I was trying to fix. It wasn't drawn to scale and I didn't want it to be confusing. For homework, skip 4, 9, 18, 23, 25, and 29. Thank you.